Welcome to the Plant-Free MD podcast with Dr. Anthony Chaffee, where we discuss diet and nutrition and how this affects health and chronic disease, and show you how you can use this to optimize your health and happiness, both mentally and physically. Hello, everyone. Thank you for joining me for another episode of the Plant-Free MD podcast. I'm your host, Dr. Anthony Chaffee, and today I have a very special returning guest, Professor László Boros, who has been on my podcast before talking about the importance of deuteronomics, which is something we'll be talking about more here today. Dr. Boros, thank you so much for coming on. It's a pleasure to see you again.
Thank you, Dr. Chaffee. Thank you for calling. Thank you for reminding me. Thank you so much.
Not a problem. And please just call me Anthony. That's fine.
Yeah. All right.
Yeah. So we've been talking off air and staying in touch, and you've been very kind to keep me in the loop with your latest developments in deuteronomics. But I would love to hear more about that for my audience. If you can tell us some of the new research that you've been putting out, and maybe just a quick sort of 2-minute summary on what deuteronomics is, and then if people haven't seen the other episode.
Yeah, sure. So deuteronomics is the biology or biochemistry or medicine of deuterium, which is a heavy stable isotope of hydrogen. Hydrogen is the most active atomic element in our body, making up about 60-70% of the atomic composition of our body and, for that matter, of the universe. And it behaves in a very particular way in biological systems, because hydrogen or protons are the energy transferring and also the chemical bonding elements in our body. And the difference between hydrogen, which is the first element of the periodic table, and its stable isotope, deuterons, or deuterium, which has a proton and a neutron. Hydrogen has only a proton and electrons. Deuterium has protons and neutrons. And a neutron, it makes it 100% increased in size and weight, atomic nuclear weight, and that makes a huge difference in biological systems. It's practically a medicine ball in the football field, and you as a football player or rugby player, you know how big a difference there is when the ball has a different weight. I think there's a New England Patriot kind of story when they they were playing with a little thingy just to make the ball lighter. And it's only a few grams. Now, in biology, we're talking about twice our weight and size of the nuclear mass of hydrogen or proton or the hydrogen stable isotope. So in that sense, because of its kinetic isotope effects, deuterium is 10 to 15 times harder to remove from chemical bonds. Excuse me, it behaves very differently in biochemical reactions. And for that matter, especially when it comes to these very precise biochemical reactions, what we call tunneling, that deuterium can deliver quite large damage to proteins and pretty delicate moving parts in our cells, especially in the mitochondria. So it seems that differentiating between hydrogen and deuterium in biological systems is key to health. And based on our studies, it's the carnivore lifestyle or the natural carnivore life and eating habits that can actually regulate deuterium in our body most efficiently. And there are some new developments, but practically deuteronomics is a study of how deuterium and hydrogen are discriminated for different purposes in our system, in our body, and in biology. And after all, how diseases develop when this process is defective or there's deuterium overload, and there are gating mechanisms that are overflown by deuterium, and what are the health consequences, and how we can use those in medical diagnostics. That's practically the framework, the umbrella of deuteronomics per se.
Very good. So this is something we spoke about before, but since then you've had some new publications and new insights as well. Could you tell us a bit about some of those?
Yeah, so we started teaching deuteronomics at UCLA when I was
Mm-hmm.
at UCLA. I retired in 2021, and that coursework continued at the Vrije University in Amsterdam. And now we actually graduated a master's student in Florida who went further and published her results in a peer-reviewed medical um, journal, Metabolomics, which is a Springer Nature publication. And the significance of this is that her name is Nicole Korczynski. When she introduced her topic for her thesis, her teachers, her professors were not really keen to pursue such a kind of novel idea of how can a stable isotope induce various human diseases and was the biochemistry behind those processes. Yet she insisted, she laid out her cards, and they eventually not only graduated her, but actually she graduated with honors.
Mm-hmm.
And one of her professors, Dr. Ann Davis, joined her as an author in her publication in Metabolomics, which is now out. And that's practically a peer-reviewed version of her thesis. And it can be read in the medical literature. So we can add this to the podcast notes after
Mm-hmm.
all, if somebody's
Yeah.
interested in reading our paper. I supervised this project, and it was actually fantastic to see how she could turn around her entire department
Mm-hmm.
and make this a official peer-reviewed publication in the medical literature of a Springer Nature publication. So it's a huge accomplishment. We are very proud of her.
Mm-hmm.
And in the meantime, I also started working with firefighters, emergency workers who have, because of the interrupted sleep cycle and circadian rhythm, some health issues where deuteronomics or deuterium metabolism is very critical. We started working with sports men. I talked to Alex McDonald, and we are planning to publish his results because he was taking some really extreme sporting challenges, running 5 marathons in 5 days while fasting. And then he did an ultra marathon, which is 100 kilometers,
Mm-hmm.
again, fasting. And we have a lot of data. We added some additional tests. We would like to see how it works out in his carnivore lifestyle. And we are working together with Alex Petrovsky, who is his doctor. So we are kind of putting this in a framework of what we already published with, for example, Ballinger, who climbed up to the Mount Everest without supplemental oxygen and a carnivore deuterium depleting lifestyle. So
No.
we understand now much better how mitochondria protects its own very delicate peptides, proteins, and really just a very logical, very simple system of getting out deuterium, this heavy hydrogen isotope from metabolism, from moving parts, and how this serves through carnivore lifestyle, what the advantage of a natural carnivore lifestyle, meaning that the products are coming from grass-fed, pastured animals, and how deuterium depletion fits into this whole picture, and how that can enhance sports performance, endurance, and longevity, health, and how it can reverse certain metabolic disease processes. What are the markers? So it seems like these publications that we put out this year in 2024, one of them is actually in the 99 percentile, so it's one of the most sought after medical publications now, meaning that we are beating almost every other paper in biochemistry as far as downloads and reads. And I'm getting these notes from Artmetrics. Now in the electronic age of communications, it's so easy to see how fast people are interested in these topics. And these are making significant waves in various areas of medicine, especially sports medicine and emergency workers, where endurance and mitochondrial health is key to survive some of those scenarios, I would say. And we are able to help not only persons, but also the medical and scientific community with this knowledge and information.
Right. So what is it about having an optimal amount of deuterium or a lower amount of deuterium that is beneficial for athletes? Do you know?
Yeah, so mitochondria is key to their performance and endurance, and also it's not only the physical performance, but also it's the mental capacity to deal with certain situations. I mean, you as a number one player, you know how important it is, quick decisions, to be focused, to be able to kind of overcome all the tackles, and those are just really simply demanding a whole body to function for in extreme situations. And it seems mitochondrial health, mitochondria for that matter, and the deuterium gating mechanisms, which starts with food and eating and so on, how important those are to actually stay fit and to be able to beat others, because that's what the sporting challenge is, after all. And it seems that because of the carnivore lifestyle brings in a low deuterium food source, their mitochondria is able to operate under low deuterium environments or low deuterium um, um, intake in that sense. And because this mitochondrial and the TC cycle unity is practically to gate out deuterium through these revolving doors called nanomotors and recycle the same matrix water that is generated from a low deuterium proton cloud that falls into the matrix, and oxygen would actually wait for those protons to make matrix water. It seems that the TC cycle is already designed, as biochemical reactions are concerned, to pick up the matrix water. So don't bring extra cellular or drinking water into the mitochondrial matrix. Recycle the same protons that are coming in through the nanomotors, and actually use those citrate synthase, citrate and isocitrate for fatty acid production, meaning that the fat that we get from grass-fed animals are already low deuterium, because the animal's mitochondria start the process that protects the sportsman's mitochondria, in the sense that mitochondria in the food chain or in biology is practically a set of potential deuterium depleting devices or scenarios when it comes to, for example, human performance, and feeding or eating habits would be where this whole process starts. And that's why we are very eager to work with sportsmen to see how they perform using various nutritional guidelines, to see how they are able to overcome certain challenges, and that's true with emergency workers as well. So it seems that because of the biochemistry, because of the reactions and the water recycling scenarios in mitochondria, this process of deuterium depletion, or regulation for that matter, is a overarching biochemical set of reactions that starts with the animals that we eat or the food source that we eat. And then it kind of multiplies as we move in the human system and cells, of how the low deuterium intake or the low deuterium food that we eat can actually help mitochondrial functions and maintain health for that matter, and how you can use this for a better medical understanding of overcoming chronic disease epidemics like in the United States. Now there is a huge kind of a movement based on the Kennedy approach of food is responsible for the chronic epidemics, disease epidemics in the United States. Now, if you look at the real picture, about 60, 70% of especially the population over 50 have chronic diseases of some sort. That includes diabetes, obesity, unfortunately, cancer, Alzheimer's, Parkinson's, and the list is very long. And now they recognize that actually the food, the nutrition, the food source is one of the basic components of this chronic disease epidemics. And it seems that if anything, then deuteronomics can provide a better understanding of how these epidemiological trends are kind of developing in front of our eyes, why everybody believes that like nutritional guidelines are appropriate. Not really. We do know that. And in fact, if you look at Nicole Korchinski's scoping review, who graduated the master's, the student that we talked about, that's her project. She's from the nutrition department. And for that matter, it was very key to see how this publication kind of review can scope out the real role of deuteronomics in human nutrition and how it can be used to develop further medical diagnostics and also therapeutic approaches to tackle these unfortunate trends in public health. And this is, I think, after all, by now it's a good and very easy to see trend in medical biochemistry and deuteronomics, and this is where we are. It's kind of a cusp of kind of understanding it and taking it further to translational and eventually to the bedside. And this is why we are so happy about these new developments.
Hey everyone, really happy to announce a new sponsor for the show and for everybody down in Australia, Stockman Steaks, who are delivering high quality grass-fed and finished pasture-raised beef and other meats, flash frozen and vacuum sealed to your door, something that I've been enjoying a lot of myself recently as well. They also have a great range of specialty items such as high-fat keto mince and carnivore beef and organs mince with liver, kidneys, and beef heart as well. So use code Chaffee today for a free order of beef mince or another specialty gift along with your order at stockmansteaks.com.au, and I'll see you over there. Thanks, guys. Yeah, that's great. I really do like how Robert Kennedy Jr. Has been pointing out, something that we all have been trying to get out there for a number of years now, that that this epidemic in this health crisis pandemic really is largely being contributed by eating the wrong things, and it's damaging us. It's damaging our biology. We're seeing the manifestations of that in our healthcare system and the
we put a huge work in this, and we spoke a few times. I probably mentioned you that we live only 3 miles we used to live in 3 miles in Los Angeles. He's in Temescal Canyon, and I was in Cantor Canyon. So and I spoke with some of his crew members just to describe the scenario. So, and how food nutrition is part of, maybe is one of the major causing factors in this chronic disease epidemics. Because if you compare, this is what he likes to bring up as an example. When his father was killed in 68, chronic disease epidemics was less than 10%, 7% of the aging population in the United States or in the general population. And now it's about tenfold of that, meaning that it's 60, 70%. I mean, in the last 40 years. So something must have happened. And apparently, since nutrition changed so much from natural food sources to processed food, and because of the quality, not only purity, but also the deuteronomics or the deuterium content of the food that the general population consumes, seems to be a major player, a major factor. So this is why we guide these college courses and these scoping reviews, just to have this effort, not just by looking at food-related poisons, meaning that agricultural fertilizers or pesticides or weed killers, whatever they use in farming practices, GMO practices, but also look at more specifically of how they affect deuterium content of food, and how this increase in deuteronomics or deuterium food content can contribute to this process of developing more chronic diseases, and not only one, but several chronic diseases in given individuals, unfortunately, and how that can be addressed from the medicine, from the medical point of view, and what can be done after all to improve the situation. And hopefully we can come up with good answers. Obviously, right now the election process in the US is shifted interest in other areas. So practically we have the main pillars of how we're going to move forward. But it is now a actively pursued agenda of the Kennedy team, and we are helping them to achieve their goals. After all, putting deuteronomics on the plate. Practically, that's our job right now.
Oh, that's great. So when was this that you were able to get in touch with him and his camp? Was that recently?
We've been working ever since. The first email was probably in 2020.
Oh, right.
March, April. Then we met a few times in Los Angeles, and
very good.
And then I discussed deuteronomics with his team, and also Dr. Seneff, Stephanie Seneff from MIT, who is part of my medical and scientific team of deuteronomics investigation. She does really incredible work based on glyphosate, GMO, and microbiome and deuteronomics, the regulatory biochemical processes behind how deuterium is regulated in our body. We do publish papers together. She's also part of this team, and she also had podcasts with Dr. Brian Hooker, who is the lead investigator in Kennedy's Robert Jr. Kennedy Jr.'s team, and so we are working very close to provide all necessary information from the medicine, biochemistry related set of arguments that can actually help this effort greatly, because this needs to be addressed sooner or later more efficiently, because these supplements, these food items, these processed food industry approach is not a solution to anything for that matter. So we are providing nutritional, and we know in fact the natural carnivore feeding lifestyle is the solution to this. Maybe if you move to politics with this, or economy, maybe with a deuterium tax on food, meaning that if it's not only kilocalories and carbohydrates and fat content and chip tax, and in Europe there are all kind of taxes now on food, we should probably add deuterium content to the food labels, and just to see how that changes these industrial processes that currently have no idea how deuterium content changes based on these processes, and see if that changes these chronic disease epidemics. So we have ideas, we have, I would say, plans for that matter. We do know how to approach this problem now based on, and this is practically just a huge effort, but we would like to provide all the diagnostics and all the therapeutics options, if you will, that can address more thoroughly this whole problem, because it's not only the United States now, it's also in Europe, meaning that Western diet brings the Western disease, epidemics. If you look at European populations, they are not better off. In fact, there are some very scary trends in public health, including chronic diseases. So we are trying to kind of ride this wave of, medical or epidemiological evaluations of how worse it is than it was 40, 50 years ago, what changed in the meantime, how it changed food processing and so on, agricultural habits. And if you look at Kennedy's program, food, water are practically hand in hand. And actually metabolic water, the quality of metabolic water is our primary goal that's our prime goal, to bring this into this whole picture. And metabolic water, deuterium content, which our body produce as long as we live, and as long as we oxidize food, the deuterium content, which is easy to measure from breath, human breath, should be part of the workup scenarios that we can actually use for treatments or therapeutic or nutritional guidelines, hopefully, that can help to bring down the rate of chronic diseases, because now it's not only the aging population, but it's actually younger and younger individuals. When I was at UCLA, I was with the Department of Pediatrics, and we saw 2, 3, 4 years old kids with type 2 diabetes, and obesity, unfortunately. So it's quite, I would say, scary, in the sense that chronic diseases are also part of the younger populations, and usually the biological behavior of those diseases is actually worse than in the older population. So now we can see younger kids, 16, 17, with Lou Gehrig's disease, which is really just a devastating situation. I get phone calls almost, even though I don't do directly medical therapeutics type of work. I'm a scientist, I'm a teacher, I don't give medical advice. I just teach deuteronomics and put it in certain context. But people call me, and people want to know what's happening in in their families, that they don't really know how to approach, simply because this young population is not supposed to develop some of those diseases that now they do. And so we put them on carnivore lifestyle. I do have friends in Hungary who actually pasture gray cows
Mm.
in Hungary, meaning that these are not just domesticated, but these are ancient Hungarian
Mm.
animals. They can survive in like almost like half desert situations because of their build, and they produce low deuterium natural food fat sources for these. We have a camp every year where we bring in like people who had medical challenges and got much better or healed
Mm.
based on carnivore deuterium depleting lifestyle. We do have the paleomedicine.
Mm.
Zsófia Clemens, you
Mhm.
probably interviewed her.
Mhm.
I mean, they do fantastic work, just simply obtaining, identifying, and kind of testing those food sources that can be used therapeutically. And we are happy to help people without medicine, without supplements. We are happy to work with sports people who actually do perform better.
Mhm.
We do have Andrea Serbus, who a triple jumper athlete, and she's a world champion now.
Mhm.
Esther put her on a carnivore deuterium depleting lifestyle, and she's a
Right.
world champion senior, and she also
Yeah, right.
keeps the world record in triple jump. So listen, it kind of, it speaks for itself. We really don't have to um, do much other than help people to kind of stay with this uh, feeding habits, meaning that to eat carnivore as much as possible from a good source, a
Mhm.
grass-fed source. We know how mitochondria discriminate against deuterium, and as long as deuterium-depleted water can be recycled in mitochondria and the fat source, because citrate synthase and isocitrate shuttles provide a slow deuterium fat source through animal. So it's kind of, it's not only a food chain, but it's also a deuterium depleting food chain. So there are now different kind of approaches to this whole idea. We do uh, provide cooking sessions. Well, Zsófia and her team provides these cooking sessions. So we united deuteronomics with the paramedicine effort, and we also brought in the Hungarian natural scientists, where I'm the vice chair of the medical and health society here in the Hungarian. It's practically the oldest Hungarian natural sciences organization
Mm.
that also try to explore these scenarios and actually teach young, like students and elementary school up, just to see how we can and how early we can start teaching deuteronomics and nanomotors functions. They love these little spinning mitochondrial nanomotors that get out deuterium, and there's just, it's fun to talk to kids and kind of
Mm.
help them through the first steps of climbing the kind of learning you know, steps of how to understand their own body better and how to select and how to live for like a better life without chronic diseases or the potential of develop, or how to reverse those in especially young ages. So it's quite interesting to see how we can help
Mhm.
doctors and families together just
Mm.
to obtain better health.
Yeah. Well, that's great. So is there an optimal level of deuterium that people that you guys have found, or that people should try to strive for?
So we believe that we actually do. analysis, breath analysis, just to see where deuterium is. We believe that the safe range in your breath vapor measuring deuterium, it's in the range of below 140, definitely ppm, parts per million. Parts per million is that how many deuterium or deuterons there are in a million hydrogens.
Okay.
And it's not a very common isotope yet. The damage that it delivers that has to be controlled, meaning that even a few deuterium can, even almost like every deuterium counts when it gets into the body, simply because it can break delicate proteins, nanomotors, but it's important for cartilage health and bone collagen stability and strength. So for that matter, we have to leave our body to control deuterium and kind of shift it to the places where it's necessary. I usually describe this to our students. It's deuterium is more like your jewelry in your house. You only put them on at certain occasions, yet they are very valuable. But if you have too much of it and somebody figures out they're going to break in your house simply because it has a certain role. It's a functional stabilized dope that your body knows how to regulate. It's a little bit of fasting. It's natural carnivore lifestyle and feeding or eating is what controls deuterium most efficiently, and your body knows what to do with it. You don't have to, and you should not overload this simply because when there's too much of it, this kind of dysregulates a whole set of very important biochemical reaction architectures, and for that matter, your body functions differently, especially if you are doing sports or you challenge your bodies. You can get injured easier. They don't heal as fast. And for a sportsman, it's not only the performance, but it's also the preparation process is just as important as, and who would know this better than, you as a leading sports personnel who have been trying this and have been doing this for long enough time to know enough of how important nutrition is in sports, for that matter, how important it is to understand what can you bring in your body to perform in a certain way. And you can test this not only through breath tests, but also there are various other strength, durability, to be able to focus, make certain decisions quick enough. And there are so many. We used to work with Brett Hundley, who started with Green Bay Packers as the quarterback, and he lived for three and a half months in 2019. He was living in our house in Los Angeles, and we did put him on depleted water, and he improved some 17% with his. They measured on what is it? One of the ESPN Sports, his how fast he throws the ball, and they have these moving objects that he had to throw the ball with different lights and so on, and there was significant improvement in his performance as a quarterback. So it's really kind of fun to see how this can, after all, serve not only the health of people who suffer from chronic diseases, but also how it can improve sports performance, how it can actually help students to obtain degrees and turn their entire department around simply because of the reasoning and the clear biochemistry, the clarity and the crisp kind of set of arguments behind deuteronomics. If you take the time, sit down a little bit, look at the TC cycle, look at a few nanomotors. I mentioned this to you that Paul Boyer, he was at UCLA, who got the Nobel Prize in '97. And I think you know his son.
Grant, well, I know, yeah, I know his daughter and his grandson. Her son was my best friend as a kid when we were down in California, and then another one of Dr. Boyer's grandsons, who was I think he was the eldest of those children. They had 5 children. Ended up working at UCLA as well as a biochemist.
Because it's in his talks and in conversations, he was always very particular to mention that this is a very unique enzyme reaction when you actually rotate protons, a number of them, based on in those nanomotors, there are 9 to 12 protons can ride any given time. And it's a very unique feature of because when I went to medical school in 1987, when I graduated, nobody could tell, our biochemistry professor could not tell how ATP is made.
Right.
So they did not know nanomotors. They did not, this just practically, it was ATP is made in the mitochondria. We don't really know how. There is a membrane potential of protons outside and inside. There's a gradient, but they didn't know exactly how ATP is made through these rotating nanomotors. And Paul Boyer was, I think he died in 2018, but he was the one who actually discovered that there's a rotating enzyme, this ATP synthase, that transferred these protons into the mitochondrial matrix, and metabolic water is produced with the help of oxygen that is coming in through air, hydrogen comes through food, and ATP is synthesized in the meantime. Now, if your body needs heat in brown fat tissue, there are no nanomotors, but there are these uncoupling, decoupling proteins that actually let the protons just to shoot into the mitochondrial matrix, and water is formed, and 1 mole of water production produces some 280 kilojoule energy. So heat is generated, ATP is generated. So the most efficient way of running your mitochondria in your body is practically to use these nanomotors. And this is our addition to this science without deuterium as much as possible. So practically, once you explain this very crisp, very visual scenario, people start understanding like, oh, okay, so this is what happened with Dr. Ann Davis, Nichols' professor, once she had the opportunity to actually, and she did fantastic work in that sense. I mean, after all, you just be able to explain this, I would say, very visual scenario with these rotating nanomotors, and people would say like all of a sudden this light bulb kind of goes off. It's just kind of lights up, and then you can just say, okay, so those nanomotors are where my ATP is originated from, and this is how our heart muscle functions. That's why we use now a heart reader to test for deuterium indirectly as a surrogate marker. And this is what we start doing with Alex McDonald, just to see truly how his lifestyle, his nutrition, his carnivore eating, and his fasting, for that matter, can actually limit deuterium in his mitochondrial nanomotors, and how he can actually accomplish these extreme porting challenges in the fasting state. Because people ran marathons before, and they did it under certain times, but I don't know anyone if he did this 5 times in 5 consecutive days in the fasting state. And we would like to know how this is possible, how this can be done, extra like ultra marathons, 100 kilometers, how that can be transferred from nature to understanding the sports performance for them better, because there are actually in Africa, there are hunters that actually run after their prey. The Hades, what they do, they run for 2 days. They just follow the herd. They can actually go after a lion and they eat lions simply because after all, the lion just kind of gives up. They have their little arrows, their weapons, which are really not deadly when it comes to fighting like lions, but running for 2 days through bushes, they are able to conquer any kind of, prey simply because they just get tired. But they don't, because they are in a carnivore lifestyle. So in a certain pace, you can run for, or maybe I can run for days. I never tried. Maybe I will. First, I want to go up as high as possible mountains without supplemental oxygen, like Mr. Ballinger did in 2017, going up to the Himalaya. Because his story is also interesting, because he couldn't do it on eating pizza and protein supplements.
I bet.
He always had to carry oxygen with him, meaning that he was not able to climb up to the Mount Everest without supplemental oxygen until he started eating a carnivore lifestyle. And that was natural food, natural carnivore lifestyle. And then he was able to accomplish that. That was his lifelong dream. But listen, if you understand peroxisomal mitochondrial crosstalk and you understand sleep much better, you understand apnoe much better, you understand why dissolved oxygen and not necessarily just hemoglobin bound oxygen can help your metabolism. This is what happens at night. You can actually just kind of go without breathing in and out simply because there's enough dissolved oxygen to run the mitochondrial and the peroxisomal beta oxidation process. With recycling oxygen, we are talking about the molecular O2. And in the meantime, you break down the hydrogen peroxide through catalase for more metabolic water. So it opens up this deuteronomics and mitochondrial peroxisomal substrate oxidation opens up a whole set of possible biochemical scenarios how to improve the system and how to explain some of the sleep patterns, some of the breathing patterns, some of the fasting patterns, like when you really just use your own body's resources. And if you have been preparing your body using a low deuterium lifestyle or eating habit, then you are able to perform and overcome some incredible challenges.
Right. And so when the deuterium level gets, well, actually, just first, what is it about a carnivore lifestyle specifically that gives you an optimal level of deuterium? I think it's great that so many people like yourself, like myself, we've all come to sort of an ancestral approach to eating from very different avenues. But it's all roads lead to Rome. It's very interesting that from all these different metrics and angles, we're finding, hey, this is actually very beneficial to eat this way. But what is the what's special about a carnivore diet that optimizes deuterium?
That's the key question here. Who can answer that, then you pretty much understand the best from the medical biochemistry point of view what health is, just to define that. So because we talked about deuterium and hydrogen, deuterium being twice as large and twice as heavy as far as the atomic nucleus is concerned, the best way to separate, first you have to separate, because they are all mixed up. It's like if you think about your school kids out in the kindergarten, there's only a few kids that are just to describe these whole scenarios that are heavier than the others. The best way to kind of find who they are, you make them run, and who is less kind of going with the crowd, that's deuterium, or that's the heavy guy in that sense. So nature has physical methods to separate these two, but this process is too slow simply because you have to make them run. You have to kind of move them around. The best way to separate them is practically to push them through a revolving door, and who don't fit, you can actually very quickly, you can just kind of separate out the heavy atoms or the heavy molecules from the set of molecules. And the revolving nanomotors, or these ATP synthase or ATP hydrolase nanomotors, are the revolving doors in biology to separate hydrogen from deuterium very quickly, very fast, very rapidly. Practically, it's the ultimate way of doing this, the fastest way to separate hydrogens and deuterium. Now, the carnivore lifestyle is practically a kind of set of species and reactions, biochemical reactions, that start with the food source that already uses these nanomotors to separate out as many deuterium from grass they eat through their microbiome, through their very long gut, through their four stomachs, through their rechewing and redigesting their food. So to get out deuterium from grass, that needs a large herbivore animal that produces deuterium-depleted meat and fat because of this deuterium gating mechanism in their mitochondria. And they use their TCA cycle citrate synthase, which takes in matrix water, which is already deuterium-depleted, into fat. And when you eat that and you burn it back into metabolic water, it's going to be deuterium-depleted. Below 140, below 135 ppm. Most, I would say, beneficial is below 125, but it's very hard to achieve nowadays because of the processed food items. We believe we can do that. We are thinking of showing this through experiments. But again, since this is part of our research agenda, we go one paper by the other, meaning that we have to provide peer-reviewed, scientifically established guidelines and translational kind of set of evidence how this whole system works. So practically, the food chain is practically a deuterium discriminating scenario when it comes to the predators. And the predators are able to overperform almost always their prey as far as speed, agility, to strength, and so on. Because if you look at like 4 lion females, they can bring down a water buffalo if it works out for them, practically because they are fast, because they are able to maneuver very efficiently. And this is what the carnivore lifestyle is, practically to be on top of this deuterium depleting food chain, if you will. And because mitochondria already discriminate deuterium in the animals, if they are grass-fed and not grain-fed, then taking these biochemical steps to all the top, which are carnivores like us, then you're able to work with a relatively low deuterium food source, especially burning the fat, long-chain saturated animal fat, into metabolic water. And because of this continuous deuterium discrimination or gating out processes, eventually you end up with a very low deuterium source that your microbiome would actually further deuterium deplete for you, meaning that your gut bacteria collect more deuterium even from the low deuterium food, and they actually recycle it in certain forms, amino acids, and there are especially proline and hydroxyproline that can go into bone collagen, where deuterium is needed for strength. So you're going to become, and this is really interesting, you're going to become a sportsman or someone who can perform, and your body weight, body fat content can be kind of optimized in a way that surely you deliver no damage to your mitochondria, even though you challenge your body and you use your mitochondria, for example, in a long marathon run or a ultra marathon, running 100 kilometers, or if you're in Africa, if you're a Hiti tribe, then you can run 4 days simply because you are on top of the food chain, but it's also at the top of the depleting set of biochemical reactions to make metabolic water for your own body, in your own mitochondria. And this is only available if you're a carnivore eating, simply because if you eat plants, those are not deuterium depleted. And if you challenge your body while you are not deuterium depleted enough, you're actually destroying a lot of nanomotors. You're asking for lactate production, you're asking for muscle inflammation, you are asking for joint inflammation, simply because your body is not operating under a optimal or low deuterium environment. And if you force deuterium into your mitochondria simply because you challenge your muscles and you do physical performance, then you may not end up in better health, simply because the food source that you consume, plants or processed food or supplements, you don't know the source, you don't know where it's coming from, you don't know what's the deuterium content. After all, and if you go to a gym and you start looking at a TV screen and you start running in like blue light, eating some supplements, you don't really know exactly where they are from with what deuterium content. You actually destroying nanomotors at a higher rate if you would just be sitting home and watch like the TV like a couch potato. And that's why couch potato, we believe, live longer. I mean, it's funny as it is, but those people, as when you look at the lifespan, it's not quality, but if you look at their lifespan, it's not necessarily shorter, but actually there were some studies showing that these couch potatoes can live pretty long. Nothing is wrong with that. Don't misunderstand me. I'm happy, if as long as you're happy with your life. Yet quality matters to me. I like to do my push-ups. I like to do my sit-ups. I like to walk the doggy. I like to be actively involved in research and teaching, and I like to interact with people who understand these scenarios and understand the benefit, the biochemical benefit. It's not I can't really give you any, I can't do this for money. It's kind of a funny scenario. I can't give you any supplements or any pills or anything that helps you in this process. But I can teach you why and how the carnivore lifestyle, if it's a natural, again, food source, the source of your meat and fat is also very important. That's just as important as what you eat, where this source is, where the source, or where your fat and meat is from. A low deuterium, natural grass-fed, pastured food source is the optimal for anything that that comes to human life. That's how simple it is. And if somebody wants the biochemical reasons or the scenarios, and this is why we publish these papers in the medical literature in open form, those are open for discussions. Please, if you have questions or if you have concerns or if you have other ideas, you can always comment. Please do so. And we are happy to answer those questions in front of everybody. The reason why we do this, and this is, people ask me to do podcasts and so on, and I'm very happy to talk to anybody anytime. It's just when we can schedule. But again, what is more important is just to be involved in this discussion based on peer-reviewed scientific articles, especially translational arm, would be helpful for physicians, patients, care providers, and so on. So this, which is happening now, has to be part of political agenda like the Kennedy's, agenda. Deuteronomics is part of our life. It doesn't matter if we know this or we don't know this, if we are aware of it or not. Deuterium is there, regardless if we see it or not. You feel it because if it affects your nanomotors and your heart functions, but have to be aware of it. And if you would like to know how this happens and why we claim, and that's what's the most important here, why we claim that only the carnivore lifestyle, natural, grass-fed, pastured carnivore lifestyle is the nutritional guide that you should consider. I'm not saying follow, but you should consider to understand in all possible contexts and scenarios. We have the evidence, we have the reasons for that. That's why I'm a medical biochemist. I'm very happy to discuss this with anyone, very happy to help people to understand this. And this is why I think this podcast is talking to another physicians, especially you who is involved in sports, and you talk to so many people in so many different areas and so many contexts. But after all, at the end of the day, my mission is to understand precisely and to be able to explain this not only to my students, but also to crew members, firefighters, emergency workers, sports people, physicians, patients who want to learn about deuteronomics. Oh, what is your optimal eating to maintain health? Now, if you are still facing medical problems, first, your deuterium level has to be brought down below 135 ppm. If we done that, and if you still come back, it's very likely that I'm not going to see you ever again. But if it happens, then let's do some specific diagnostic processes and find out what's wrong with you. Because just based on your nutrition, there shouldn't be any problem with your system, with your body or your performance or your sports injury to go away or practically to heal faster, to just like do it in. I usually eat once a day because I like to be hungry a little bit. It's not really hunger, but you kind of keep your eyes open for the best food source, and when you find one, you have some. You don't have to overstuff yourself. Eating is really, you're much better adapted to a low food intake simply because our metabolism has no biological safety threshold. It's not like our femur or a leg bone that can actually support 8 times of your body weight. We don't have to, metabolism doesn't have to work with or shouldn't be working with 8 times of the food energy that it can process or metabolize or oxidize, because there's a little strict constraint here is that the available oxygen and how it's delivered to your tissues, because that guides your energy production. So if you understand this constraint, how it works most efficiently to support your ATP synthesis and your mitochondrial health, that's the key to understand health in general. And the most optimal way of doing this is practically a carnivore, natural, grass-fed pasture lifestyle.
Nice. So you mentioned collagen is certain connective tissue that has higher levels of deuterium. This is sort of natural. Your body sequesters out and separates out the deuterium in the areas that it needs more and areas that it needs less of. What is it about collagen and connective tissue that requires more deuterium?
So that's also a very interesting topic, simply because Dr. Roman Zubarev, who is at the Karolinska Institute, he was in Budapest in 2019, and he was my chair and I was his chair when he was giving his talk, and he was talking about amino acids that accumulate deuterium, especially proline and hydroxyproline, which is 20% in collagen, 25% in collagen. It's the most common amino acid in collagen. And in the meantime, we know bone and collagen, how strong and how kind of flexible yet very strong and tight compartments make these tissues, connective tissues, strong and able to kind of withstand phenotypic challenges. We'll talk about gray seals, peregrine falcons that can actually dive like 400 kilometers per hour in air, and they have to slow down in the last 50 meters of their dive or these stoops, simply because otherwise they would not be able to catch their prey. Their prey would fall apart practically if they catch it. So because of this very friction, very like huge physical friction, their wings are exposed to, or if you look at the gray seals, they have to escape from white sharks, from killer whales. They have to dive 100 meters in matter of minutes or seconds. Their bone structures have to be very strong. So for that matter, collagen uses high amounts of deuterium, and now we are talking about 315, 320 ppm versus 125 ppm in the optimal scenario. So almost two to three times more deuterium in in bone collagen to be able to withstand those physical forces and demands these animals are phenotypically exposed to, meaning that they are either eaten by the killer whales or they escape, dive fast enough so their bones can withstand it. And their cartilages, their femur bones are loaded with deuterium, and that's true with the falcon. Now, if you look at the swan, which just kind of swims on lakes and there's no really predator that chase them, their deuterium level in their collagen is 150 ppm. So there's really no difference when it comes to the environmental deuterium level. So it seems that deuterium is a phenotype-related atomic component of strength, durability, and to be able to perform in extreme environments. And there was a very interesting paper in the proceedings of the National Academy of Science of the United States, or PNAS USA, describing differences in fatty acid deuterium content in tumor cells compared to the water that they were harvesting these liver cancer cells. And they published this study in the PNAS. And then what they saw is that even in a tumor cell, when things don't go too well, meaning that they divide constantly and they form very bony structures, meaning that they are really truly different in touch. If you're a surgeon and you operate in brain tumors, you can tell their touch is different than the brain tissue. And that's especially true of skeletal or connective tissue tumors. So practically they show this very broad distribution of deuterium among and between cell compartments and molecules, fatty acids, and water in tumor cells. So we wrote a letter to the editor of this PNAS article, and we told him, listen, this is actually a very general scenario or platform as far as deuterium is distributed in biological tissues. It's practically a phenotype related matter of how much deuterium certain amino acids accumulate, and that determines the phenotype. So we wrote a letter to the editor that intermolecular, intramolecular, and intercompartmental deuterium variations define biological adaptation. And they published it, which means that it's really, this is the second kind of most cited journals on this planet. And now we have an argument of how deuteronomics or deuterium-related sciences can explain the diversities that they describe from Princeton in deuterium content in tumor cells of fatty acids, and they can differentiate between among oxidative metabolism versus fermentation based on these deuterium mapping or deuterium maps of molecules in these tumor cells. So we argued immediately that, listen, deuterium has a very fundamental role in defining these phenotypes. Bone collagen is strong because of the 15 times harder to remove deuterium from a chemical bond when it's in a protein and a hydroxyproline. Dr. Stephanie Seneff is doing a great job to define these kind of diversities in deuterium distribution based on microbiome. And with Dr. Zubarev, Roman Zubarev, he's the Karolinska investigator who studied gray seal and some other species, how deuterium is distributed in their bodies, and found these high deuterium depositing collagen tissues in gray seals, but not in the swan. So they started immediately thinking of how can, first of all, deuterium go above natural abundance, meaning that what biochemical reactions can collect deuterium. Because if you look at physics, laws of physics, you should not be able to exceed the ceiling of a stable isotope concentration looking at physical forces. It's practically, if you climb mountains, you cannot climb higher than 8,000 or 9,000 meters simply because there's no higher mountains. Physically, you cannot go higher than. And that's practically the end of the equation, but not in biology. In biology, yes, you can. In fact, that defines certain unique phenotypes and what the biochemical reactions that are involved. That's what we described in this PNAS letter to the editor. And that was an immediate hit again, because it's a very important argument. They usually sit on these papers for about a month, 2 months. They have to digest these. They have to talk to senior editors. Like, what should we do with this set of authors? Because I don't write these papers by myself. I always kind of do a draft, and then we all put in our own approach and our own vision of how this is possible from different angles. And it's really interesting to see how, after all, deuterium in bone and collagen, and this is what we do now, we look at different species based on their weight, based on their size. I just got some samples from British Columbia, from Jacqueline, the Canadian friend of ours who changed from a processed food scenario to, I think you talked to her already, or you are planning to talk to her, or
I don't think I've gone there yet. Yeah.
Not yet. She
No.
moved from Toronto to British Columbia, if I remember well, and they bought a land just to grass feed to pasture animals, and that's what they eat now. And we are measuring deuterium level in those animals, and also in certain products in their environment. And her chronic diseases are gone, meaning that listen, she couldn't move farther from the house than the garden, and her husband had to make this little chair that she could actually move in the garden to kind of take care of certain things. And now she's milking 10 cows a day, eating a carnivore lifestyle, and all her chronic diseases are gone. And practically, when you put all these, and it starts with understanding how collagen, how bones, how skeletal structures and connective and supportive tissues collect deuterium, certain amount of deuterium that is enough for their environmental phenotypic challenges, their lifestyle, and how this can be fit in and with other biochemical kind of reactions involving the microbiome, involving certain organ-specific metabolic scenarios like brain, heart muscle, skeletal muscle functions, and how these scenarios make a whole body to function better. Because after all, it's really a very complicated system simply riding on a very few denominators, and deuterium in food and how you regulate that seems to be one of the major players in this area. So this is why I'm kind of so happy to be this far in this alley, simply able to not only talk about this, but also publish this in the peer-reviewed, very strong medical and scientific literature in an open forum. So anybody has questions, or anybody has input, or anybody notice anything that we should be focusing on, or have questions, or have another idea, or have some ideas, we are very happy to discuss these in public in front of the whole scientific community in an open access forum, because I think that's the best way to kind of move this field forward.
Yeah. Yeah, I think I agree. Um, you said something interesting earlier as well, that 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 the circadian rhythm and can actually affect your deuterium levels as well. Did I hear that right?
Yeah, that's right. So
Hey guys, just want to take a second to thank our sponsor, Carnivore Bar. I don't promote many products because honestly, all you need to be healthy is to just eat meat. For those times that you're out hiking, road tripping, or stuck at work and you want a nutritious snack that is just meat, fat, and salt if you want it, the Carnivore Bar is a great option. So I like this product not because it's just pure meat, but also because I want the carnivore market to thrive as well. And the more we support meat-only products, the more meat-only products there will be available in the mainstream. So if this sounds like something you'd like to get behind, check it out using my discount code Anthony to get 10% off, which also applies to subscriptions, giving you 25% off total. All right, thanks guys.
That's how I got involved with firefighters in deuteronomics, simply because they retire early. The sleep is practically nothing else to regulate deuterium through peroxisomal mitochondrial. You need to get in ketosis to be able to deplete deuterium efficiently, and sleep is the best way to do this, simply because you're not eating anything. Even though you're hungry, you burned up all the sugar after 3 hours of sleep, because of these rapid eye movements and muscle activities. You burn up your sugar very efficiently and very quick, and your glycogen to some extent, and you have to start burning fat to have to get in ketosis to actually sleep through the night, meaning that sleep is practically to get into ketosis deep enough that you can start a new day. And because you're not eating, so you're not able to load your body with carbohydrates, and those carbohydrates run out after a short period of time. I mean, relatively after a few hours. Now, if you disrupt the cycle, if you wake up in the middle of the night because there's an emergency, what happens is your body immediately reverses these mechanisms because of adrenaline and because of the suprarenal gland hormones. You start burning glucose again, you start mobilizing glucose from your glycogen store. And what is worse than that, once your emergency situation is over, meaning that you return to their base, you can't sleep for the rest of the night, so let's get a donut. I mean, or let's turn on the TV. Because these shifts are, it's, being an emergency worker is not as simple as just you go drive around a little bit and then you go back to sleep. No, those are very challenging situations, and you may not be able to go back to sleep because of your adrenaline, because you've been in a fire, you were saving people's lives, you were cutting cars in pieces to rescue people. So that's a different scenario. So you not only disrupt your night sleep, but you also disrupt this deuterium depleting ketogenic metabolic adaptation that is part of your sleep cycle. You are not reaching ketosis enough, especially if you eat in the process. That's the worst you can do. And if it's a donut, that's even like not only disrupt, but actually you start loading your system with carbohydrates and unknown source of deuterium that your body really is not prepared to deal in that situation. So because of these health challenges, they can retire early. But early retirement is really not a solution to the problem where you already delivered such damage to these mitochondria because of these repeatedly disrupted sleep cycles. And they do 12-hour shifts. They do 12-hour shifts several times a week. And because of these disrupted regular sleep cycles, they start developing chronic diseases. And some of them are unfortunately belong to these very hard to treat with medications, including diabetes, obesity, and what is the most, I would say, disadvantageous situation is failing hearts. So, because your heart operates differently than than your skeletal muscles. Skeletal muscles get a nerve signal, a motor neuron delivers a signal through acetylcholine signaling through the skeletal muscle, so you can contract your muscle efficiently. And when it's done, you sit down and rest a little bit. Now, heart muscle operates differently. It doesn't depend only on ATP during contraction, but it also floods the cell with calcium, meaning that calcium, because of the conformal changes in those heart muscle proteins, actins, they actually contract, but it also requires an ion influx, which is calcium in that matter, that during the relaxation of the heart muscle needs to be pumped out. And that's also an ATP hydrolase related. It's also a nanomotor related process. So while your skeletal muscle only needs ATP while contracting, heart muscle needs ATP or nanomotor functions when it relaxes too. So it's both the contraction, and so it's kind of a never stopping scenario to use those nanomotors. If you know in medicine, when you want to challenge somebody metabolically, they put them on a bike, they give mask, and measure carbon dioxide exhalation and oxygen inhalation, and they calculate metabolic functions from there. So you have to make muscles work continuously to be able to determine their metabolic activities. Not with the heart muscle. The heart muscle needs ATP, and it contracts and relaxes all the time. So we started using this little heart reading machine, which measures the inotropic slope of a heart contraction in 2 minutes in a row, about 140 times. And based on these slopes, we can determine how efficiently heart muscle is able to contract and how the next contraction is able to be the same in strength based on the calcium efflux from the cell of the ATP ACE function, meaning that we can tell how efficiently your nanomotors operate in your body. That is easiest to measure when it comes to heart muscle function. And if you do these measurements based on these inotropic slope changes and the regularity, you can actually use this as a surrogate marker of how these nanomotors are able to rotate in your body. And that's mostly, we believe, is related to deuterium content of your tissues. And we use this as a surrogate. Again, this is not a direct deuterium measurement like we do this in breath, but actually we can use this data, we can use these slopes one after the other. In 2 minutes, we do this 140 times. So, so practically, this is a very easy and simple and online remote approach to measure deuterium indirectly in your body. And this is why we start this type of measurements with healthy people, with sports people, with firefighters, because in the firefighters, if you disrupt sleep night regularly, circadian rhythms, unfortunately, and this is what's really interesting about their work, is that it actually affects your heart muscle dominantly, meaning that some of these firefighters, they not retiring only because they can, it's because by then they really do have some heart challenges or some health challenges that affect their heart. So this is what we are trying to address. And this is the important, I would say, for emergency workers in general, this is something that we would like to provide as a potential solution. First of all, once they return to the base or to the unit, once they return to the unit, they are not supposed to eat anything. So there's a lock on the refrigerator. If they come back to the unit and they have to drink, that needs to be deuterium-depleted water. If they are hungry, then we would just recommend of bear with your kind of hunger long enough. You reach maybe like morning hours where you would eat something that is grass-fed, something that is animal. So stay away from processed food, stay away from sweets, stay away from carbohydrates, which is during the night, your body is not supposed to be exposed to any food, especially carbohydrates, and it's supposed to burn your fat and deplete deuterium, provided that the fat was the right source. Now, the problem with the emergency situations is that mitochondria and the TCA cycle, the Krebs-Sanjurji cycle, can work either in the catabolic way or it can work in an anabolic way. In biochemistry, we call this reductive carboxylation. If that sets in, especially under a stressful situation where your physical demand is increased, then unfortunately your fat deposits, your fat pool can also be deuterium loaded, because the reverse way of using mitochondrial biochemical reactions do not deplete deuterium. So, and that happens in emergency situations. Your mitochondria function differently because of the physical strength that you have to. You're in an oxygen tank, especially if you're in a smoke. So you can't. It's a very challenging, demanding metabolic situation, and for that matter, you have to go in that situation with the lowest deuterium as possible and keep that as low as possible during the night to preserve your health in the long run. So that's the idea. So they can retire early, but they still have good quality of life. This is our primary goal here.
Yeah, good. So, well, thank you for all that. That was amazing. So
Sure.
what are the future plans that you have for your research?
So I think we did the academics, the publications, the scientific arguments, the evidence are out there.
Mm-hmm.
So now we are looking for applications, or we are positioning deuteronomics in the PNAS letter that we wrote. We named deuteronomics depletion, which is deuterium depletion. We talk about the human deuterome, which needs to be as important as the human genome or the human proteome. The human deuterome is just as important, simply because MRI images can determine ratios of hydrogen and or protons and deuterons in tissues. That's how those images are generated. Of course, there are electron and proton spins and so on, and delocalization scenarios, which are nuclear quantum effects. So I don't want to go that deep into this field, but practically deuteronomics, or the human deuterome, which is now in the PNAS letter, and I'm very happy the editors was not overnight, but eventually understood of such a prominent scientific journal of how important of the human deuterome is, for that matter, of how much deuterium is in your body, how much deuterium you can discriminate and use for building collagen and bones, which is kind of interesting that your body can, and this is very old text from the Old Testament, that actually the Old Testament already asks, how can bone develop in the woman's womb? So simply, how can a stronger tissue be formed in soft tissue? I mean, just to translate this to the deuteronomics realm. So it's an old question in that sense, that now we have the ways of explaining this by proline and hydroxyproline deuterium enrichment, which is in the 350 ppm range, and that's going to provide a connective tissue that is strong enough with inorganic material, calcium and phosphate, to form bones that are actually still flexible enough. They don't break immediately, so it's not an osteoporotic. So it's practically just, it affects all areas of medicine. It's part of all areas of medicine, including diagnostics, performance, health, chronic diseases, and so on. This needs to be brought in, applied to different fields, different scenarios, different challenges. And from there, we can actually use this knowledge to tackle some of the epidemiological disease trends, chronic diseases, and so on. We think that this needs to be part of medical discussions, need to be part of policy making and decision making, and it could be even part of, let's say, food quality assurance, simply measuring food deuterium content, and just like, you know, any kind of pollutant or oncoisotope or you name it, you can just test for it under the deuteronomics or the human deuteronome umbrella. So now we are actually applying this to various fields in medicine. The basic science, the arguments, the evidence are already imprinted and embedded in the medical literature.
Right. Oh, that's great. Well, Lazo, that was fantastic. I really enjoyed that. It's always great to see you. Great to hear about the great work that you're doing. Thank you so much for coming on. Where can people find you, see more of your work, and support you in any way?
Yeah, so I do have a website. It's very easy to find. It's
Mm-hmm.
laszloboros.com. And our papers are available on my website, but those can also be searched for in PubMed. You just put in my last name, Boros, Boros, and maybe Dr. Senef or Dr. Kyriakopoulos. He's from Greece. We have two Italian colleagues, Dr. Priscopo and Dr. Brogna. They are proteomics experts. So if you look for my name in Medline, Boros LG, you can see those papers. And also my website, I put all my podcasts, I put all my conversations with a English transcript. So you can actually follow the trend of how deuteronomics developed. I'm very thankful to all people who have Dr. Keltz, yourself, Esther, and friends who actually have this and make this field better and larger in the sense that more applications are found. I'm very happy and thankful for the sportsmen, firefighters, emergency workers, doctors, colleagues, and the list is, if I forgot someone, I apologize, but practically it's been a 15, 20 years of studying deuteronomics, and I'm very happy to say this at the end, that deuteronomics never let me down. And regardless of all the challenges, and I'm very happy that we could kind of provide a new technology, a new way of looking at things, and hopefully this can be part of everyday thinking, just like many other important kind of thought processes. You have to be aware of deuterium to be able to kind of design your day. That's how I usually just approach this.
That's great.
Thank you so much.
Oh, thank you. It's been a pleasure as always. Thank you everyone for joining. I hope you enjoyed that as much as I did. And I'll put those links down below in the link for Dr. Boros's website, and you can check out more of his work there. Thank you all very much. We'll see you next time.
Thank you.
Hey guys, thank you very much for taking the time out to listen to what I had to say. If you like it, then please like and subscribe to my YouTube channel and podcast. And if you're on YouTube, then please hit that little bell and subscribe, and that'll let you know anytime I have a new video out, which should be every week, if not more. And if you could share this with your friends, that would help me get the word out and let me know that you like what I'm doing. Thanks again, guys.